Hey, I wanted to do a follow-up video to the week 3 class. In one of the sections, we had a glitch in the radiation map workflow for a moment or a couple minutes, and I wanted to go over that. And then we talked about, I really pounded home the idea that I want you to have layers organized in your models, and people were asking me if I could give more information on that and maybe give a list of the layers. Finally, I'm going to just show the radiation simulations I ran in the 413 section to sum up the point of that and just remind us how it works. All right, so first I'm just going to do a quick radiation map. I'm going to start it from scratch. I'm going to build, let's see, I'll do a 50, maybe I'll go 20, 25 feet. I'm going to make a box. Let's just go and be organized here. I'm going to say building. Then I'm going to copy it twice. If I hold it Alt, I can just copy, right? So I'm going to move this one back over here. So now I've got, let me just make this really obvious. So now I've got a building. Make sure I change that object layer, and I'm going to make these two shading. I've said before I don't like, let me just make sure I'm doing this, change object layer. I don't like colors on my layers. That's my personal preference. You can do whatever you want, but I find it confusing since especially when we're running simulations, we have colors. And then secondly, why do I want colors in a model if they're not relative to the building? So I just don't get it. But that's me. Anyway, so now I'm going to run a radiation map simulation. First thing I'm going to do is add my analysis surface. And I'm going to add that to the building that I chose. I'm going to say, okay, I'm going to go ahead and put these at 5 feet on center just so we'll have more of them, but you don't need to do that. And then I'm going to add materials to my buildings, and I do that by clicking on the materials setting in the radiation map, and I add, which I've already done here. Let me turn it off because I guess I played with this before. I didn't realize I'd already used this file. I'm going to clear it. So let's go back. I have a building on a building layer, and I have shading on a shading layer. I've made the building into surfaces on this tab. I'm actually going to change its name. I'm going to call this building. And I am going to set the materials for the shading. And again, this is a super lame radiation map. I'm just trying to show you that this works. If I hit run now, we see I get an output, and clearly these buildings are shading. If I turn them off in the model, so if I come back here, let me actually name that shaded. And then if I I'll just turn off the buildings and run this again. I see that I get very different results. All right, so my not shaded, on this sensor I'm at 303, and here I'm at 188 because I had a big building next to it. So the point is, this workflow works. There was like at one point in that class, I exploded my shading context. The reason I did that was because for a different simulation, the energy simulation, which I ran quickly also in class, we don't want to have we want to have individual surfaces because, for example, if I come back over to my full model, let's say I have this model, and I made all of these buildings surfaces. First of all, that'd be a huge amount to calculate. It would take forever. But also, if this building, for example, is a solid and not individual surfaces, then it confuses the model because the model needs surfaces in order to say, well, how much sun is hitting, how much is this surface shading my site? It needs to see it as a surface, not a solid. All right. So the point is this works. Why didn't it work for me? And why am I pretty confident that that's not going to happen to you? let me show you that if I go to CS version, I'm in install version v20. Now you might be there, but I think most people when you've been downloading have been going to the stable release. So basically what's happened is that Climate Studio has just created a complete update, so a new version, V2. I've updated to it. I'm, the ambassador for our school. I'm supposed to keep up with what's going on. I think that's what the glitch was. It was just something in the new version. I don't think you guys have that. I think you still are in the stable release because I have a different setting. I'm downloading even I'm downloading their versions before they've been completely vetted. Um, so like, for example, if you went to look at yours, yours probably set on service release. I'm on service release candidate. Anyway, so that's why sometimes in class I may run across a glitch or something that you won't experience. Okay, so let's talk about now this concept of layers. So here I am, and this is the design, the comprehensive studio design for site for this semester. This is your library right now that you're, this is existing, and this is the site. And let's say this was your full site. The first point I've made is that I think that often we'll want a smaller site for the kind of stuff we're doing. So I'm arguing that we want a full set of layers and this is all just these are just I brought them in from it's a site, it's a site. I'm sorry, CAD Mapper site model. And then in class I have trimmed that down, uh, right, to something like this. Let me fix it up here. I want this with the plinth. I'm going to turn off my, let's see, that's down here somewhere, I think. I'm looking at this building site that's here. So I created a building site. Anyway, so the point is now I've got my little plinth topography on a separate set of layers. I can turn on my full site or just have my trim site on. And by the way, I went in, and this is why I can't really just give you a set of layers. This is really part of the process of you learning this software and you being an architect and deciding what makes sense for you. I do want you to have these things on layers because it's the only way you can organize it, but you can copy me if you want to, absolutely, and I will try to give you any information you need. But the better approach, I think, is or a different approach that I think will be better is if you think this through yourself. So what I did here is I went in and organized this a little bit more. Like for example, I created a main layer in my trim sites that I have that building site for the project that I made. I also have the library, so I can turn off things that are specific to the project just by clicking that one um, main layer. I have all the buildings here, and I took all this infrastructure stuff, what I'm calling infrastructure, which is the roads and the subway, etc., and I put that on an infrastructure layer so I can turn it on and off easily, and I can also turn on and off my topo easily. I also then, like I said, I created a separate site here for the project itself, the green. Okay, so that's the first thing. I'm saying we have to have a site, and we could have two sets of layers. We could have 10 different sites if we wanted to in our model. I also would suggest creating, I call it tools. You can call it whatever you want to. This is where I throw all the stuff like, when we trimmed this volume. I also, like for example, this point right here, I think I used that when I placed a windrose. Um, yeah, that's right. I think it's sitting on that point. So, I just kind of it's just a grab bag of stuff for me, so that I can use it. So I can go back and easily, like for example, that I may not want to get rid of this um, trimming surface because I may need to trim something that I didn't catch, or I may want to, make another version of this or whatever. Okay, so I'm going to turn that off. So now I've got tools and my two site sets of layers. I'm, I would think that you would have an architecture layer, and this is where all your studio stuff goes. Now, here's where we start getting a little more complicated. Now, you don't have to create, like for example, I wouldn't have to necessarily create a radiation map layer. I could do it in architecture. I find it for myself much better to repeat myself in individual layers, layer structures for the simulations I run. But what that does is I start repeating, like for example, I've got massing 1, 2, and 3 here. In my architecture layer, I also did massing 1, 2, and 3. And so I start getting repeated sets of layers throughout the model. That might confuse you. That might, there's certain, you can quickly, if you're not like a lot of times when I'm modeling with you guys in class, I'm trying to get it done and I'm going quickly and maybe I am not as disciplined as I should be and, things get confused. That'll happen to you too, of course, because you're always just wanting to work. We don't want to always spend time organizing. So it's somewhat up to you. But I'm suggesting that you create an architecture layer. So that way now I can just turn off everything that has to do with this class and I can be building something in the architecture layer and it doesn't have to be related to simulations at all. It's just a bunch of massing that I made. Um, massing 1, massing 2, massing 3, super basic. I'm not trying to design like as you guys are. Um, okay, so then the point being that this would be where you'd be working in studio, and then when you come to this class, or hopefully when you're in studio thinking about simulating, because that's what you're supposed to be doing, is applying these and iterating and using outputs from simulations to improve your designs. Then you could go, you know what, I want to, I'm ready to go. I chose these massings and in class. I'm going to right click on this, hit duplicate layers and objects, say yes to all, and get a new set of those and move them somewhere else, which is what I did to the radiation map, my radiation map layer. I'm going to delete that. Okay. So then what I'm saying is that, for example, this week, then I created this set of layers, and I did this kind of on the run in class, and then I went back and cleaned it up afterwards. So let's just go through these. I'm going to turn off, let's just at least turn off my site for now. I mean, my building site. Um, and I mean, the building site for the project. Yeah, I guess it's clear. I'm going to turn on my whole radiation map. I'm going to go and turn off everything except that for right now. So the first thing we can see is I have context. And here I have a flat site that I decided to make. And this is really for graphic purposes, because if I come in, let's go over that. So if I turn on my trim site and I have a topo on, and actually I'm going to turn on not my my plinth. I'm going to have the original topo. We can. This is something that's come up as to whether or not this is I don't know what the best way. Let's look at it here. Actually, let me go back up to here. Um, so if we zoom in on this, we can see definitely that there's quite a bit of, uh, even though people are saying it's a flat site, it's not flat. Um, I'm going to turn off the buildings so we can see just let's see, sorry, my massings. Let me just leave on one of them. Do I have the massing layer on here? I do. Oh, that's the library, sorry. Sometimes, this gets like this where okay, I'm going to turn on the context. So that's a good point there. So I built that context base, and that's from the original model, and it's sitting up off of this is what the model is considering ground. And I think what it does is it just finds the lowest point for the site you brought in, and it makes that the construction plane. So we can see that we're, a number of feet above that with the buildings that we've got set here. So if I bring in one of my contexts, then I'm above um, this uh, construction plane, which you guys in studio probably are considering the actual site. But if I go turn on now my topo, not the plane. Okay, I got to do this way. Turn off that. Okay. If I turn on this, we can see that these buildings are cut through by the topo. And so what the model has done is just, it hasn't set them in, that'd be a whole complicated thing to do. If you're, these are just taken from GIS information. It's really cool that they can make them so quickly. So we'd actually, we'd have to determine if this is are we cutting back the site here? Are we, digging a foundation? Are we lifting it above? So, but it does affect us because right now, then if I do a radiation map, some of my building would be shaded here, which is going to affect the numbers we get. But maybe not greatly, and maybe this is just a class. We're not worried about it being completely accurate. So I'm going to stick with that. And so let's keep talking about. So I've got that's my flat context. Why do I have this building way down here, and why might I actually want to use the larger flat context that I have here? The reason this building is here is because I went to my site analysis and I turned on my buildings, and I'm sure I had the topo on at this point because I want something for the shadows to go on to. And I went through a year and tried to consider which buildings are causing shade on the site. And like so, for example, I can hide this building. Oops. Oh, I had two things. I have two versions of this on right now. Three actually. So I can look and see that there's a little bit of shade there that's happening from that building at that point, but somehow I went and I found, maybe I took it further even. Um, and if you watch right here, there's definitely some shade coming from this building. So my point is, this looks nicer to have all these buildings here, and so you can leave them on when you're creating graphics or even when you're running your simulation. But you want to pick. It's a good idea, first of all, for speed of your simulation, but also for understanding your site to go through and decide, okay, what is actually shading my site, and then just picking those buildings for your. Well, we can see right there that it's, well, but there's other buildings around it. So, for example, you know, these buildings right here, you would think they're going to shade it, but first of all, these are far enough north that they don't. This one is completely, its shadow is completely redundant to that one's shadow. So that's why I didn't include it. Okay, so we go back to trimmed, take that off. Maybe just make it clear. I will put on this larger trim site, flat site. If I do that, maybe I'll turn off this context flat site so we don't get redundant. And I should make sure I've turned off the topo. Yeah, so there we go. So what else do we have here as a layer for this week? I had the flat site. I also have a topo that I put on this layer. And this is a good example. Oh, and this is I think this is why I did it even, was just to show this example. But also, if I ever want to use it, I don't need to use my plinth for shading. So I have both of them here, I have a flat side and a topo if I want to use them. And then I also have just the, let me turn this off. I have just the buildings that are going to shade my site that I have, that I'm going to give a material to for the radiation map. And so just to finish that thought off, yeah, let's turn this off for now. All we have to do then to run the simulation, the radiation map, is to add surfaces, first of all, to the site, I mean to the building. Remember, there's two things we're doing. We're deciding what surfaces we are going to measure the energy of the sun hitting. So that's our testing surface. And so in this case, I gave, and right now we're talking about massing 3. I gave I exploded my volume, and I made each surface separate so that I'll get separate readings for them. And I added them here like I showed in class. And then for materials, I have the context buildings shaded, and then let me just turn back on. I'm going to need this flat site because it's the one I used for the. I mean, I could change it, but so I've got flat site, which is this little rectangle here with asphalt, and context shading with concrete. And that's it. Then I can run these simulations. So let's then look at my results and kind of how I organize this. First, remember, you need to start naming these simulations. You're gonna have a bunch of them eventually. That's when we'll start creating a second file or a third file, and because we just don't want to have 75 simulations in one model, and it gets to be unruly in terms of just trying to find them and follow along. But for right now, we have them all here. I'm going to go and just for my own visual clarity, I'm going to turn that off. So what did I do? And I'm gonna, okay. So no, sorry. What I'm saying is that we need to name each of these simulations in a way that makes sense to us. I would do it though always with letters because this is how this is organized in terms of the following. If I hit date, it's gonna, if you go back, you look through this, this is how the dates on which these were run and time, so it organizes them chronologically. I want them to be organized in however I want to organize them, so, because I want to maybe be able to rename these and move them and change the order. So if I name them with these letters, then I can go to A to Z and ZZ, or AA, whatever, or ZZ onward, to get more than 26. If then I am ever in a situation which often will happen, where you'll think that you're like I am right now, see how I'm not in order. The reason that is because it went back to date, and that's the default. So if you just click on that a couple times, hit name, because now I can go either up or down chronologically by the name. So that's the process for that. Remember, I talked about how you have to name your file and where these simulations are. If you have questions about that, you should ask me in class. So the final thing is that now let's look at one of these simulations, the first one. I'm going to turn off my massing for sure. You should decide what's the best way. Maybe ghosted might be a better way of showing these. The best way, maybe at this point, I'm going to turn off this, because what I'm saying at this point, this is graphic layout. I'm not talking about simulations, and so I can put other things on in the simulation than in the window than we're actually run in the simulation to create the context I want, or not. But anyway, so my first simulation is M1 no con, so that meant massing 1, which is this. Actually, it's probably massing 2. Let me turn this off. I might have actually. It looks like this is at the end of class. I probably deleted that one. But anyway, let's forget that mistake right now. It doesn't really matter in terms of what I'm talking about. I had 3 massings, 1, 2, and 3. Actually, that's true. I think I had 4. Well, let's see what I get here. So first of all, we'll notice that my sensors are pretty far apart. This says no con, so it was without the context. And so this is sort of a baseline, just the climate file without context. I see that I do get a gradient like I would think. I get the most sun on the roof, then the next most on the south side, then east and west next. The west has more than the east here, and then always the least on the south, on the north, in an open situation in our climate. Then I did, the next one was M1 with context, and I can see, so I can click back and forth between these really easily to see the differences. And what's going on here, right, is that it's the context from the building. So let's turn that on. But remember, then it doesn't change the output from the simulation when we turn things on and off after we run it. So you want to remember, that's why we're writing these things down here, so that we can remember the context that we did the simulation in, and then use that in our understanding, and also then if we're creating graphics. So in this case, we're seeing that these buildings weren't here for M1 no con, and they are here for when I bring them in, they add shading. So it's 300 to 120. Right now we're in kilo BTUs per square foot per year. In my undergrad section, we talked a little bit about this. The very good question came up, which is like, what's enough sun? How do we know what's enough? Right now, we're talking relative, and what we're talking about is what do I want? What do I want to start thinking about in terms of my design? As you are starting massing, you should be thinking about, I want a really nice sunny outdoor space, or I know that I want to have a big reading room that's has a lot of glass because I want to have a beautiful view, but I don't want it to be glary in there. And so you need to start thinking about, okay, well then that, and first of all, you don't know all these things yet. I mean, we've been teaching you this, through your time at NYIT, but you're beginners, and so it's fine if you're just like, I don't remember how this works, or I've never learned it. But the point is that you would be applying the things that I talked about earlier in this semester, even in the introductory lectures, and like the knowledge, for example, that if I don't want direct sun, north is a good place to do it. Side lighting anywhere is a good place. We'll talk about that later. But then also, if I want sun for heat, then I can compare here. Definitely the roof is going to be the best for that. South is uh, better than east or west, because here's the other thing. Remember that you would click and say, okay, actually now I'm talking about sun. I'm talking about heating. I want it to be in the winter, not all year round, so I switch this just to the cold hours. Um, and then I see a much larger difference, like 30 kilo BTUs per square foot per year here, and then 122 over here. That's 4 times as much, just right around the corner on this building. Um, okay, so that's A and B. Let me go back to the full year, or the all hours. Um, And then, now I remember what I did. So then I moved my M1 massing to a different place. And so I can compare this placement. At first I did it without a context, which is kind of, okay, let's just do that. I can, the without a context really isn't helpful to us because we can't get rid of the context, but it helps us learn things. Um, if I compare these two, it's very similar, which is what it should be because there's no context, right? But then if I compare um, this to this, then we get this to this, we get a pretty big, range. So for example, here it's 318, um, and here much lower because there's a building there, right there. But let's see if we get much difference on the west. We got 228 there and 170. So quite a bit of difference by moving, and this, if we had a building this size, we could move between these two sites, right? So that's the idea. You're thinking about, what's my available building area, which I put here, and what are the options I can bring into play with the space I've got. Okay, so then let me turn on a topo down here, I guess. Okay. Then I moved on to second massing. And you'll notice then, as I'm turning on off these massings, I don't need to have those layers on here. I don't want to have them on because this is the surfaces that were used in the simulation. And so here I'm comparing the difference between this siding for this massing and that siding. You'll see that I changed the number of sensors because I'm getting ready to do something else that I wanted more sensors on. But I can still, compare these two positions based on, first of all, graphically, it's very clear there's a difference. Um, but, there's probably not going to be any difference in the north. So, there's lots to learn here. Um, so I can be thinking about it. Again, this massing is just super basic. I just made a volume that essentially pretty much fills the space. I try to make it something that would be in the ballpark of the square footage that was in your program. And so then the final thing I could do quickly and I would want to do, so let's say we're back what we were saying. I'm thinking about large open spaces that I want to be sunny. I'm thinking about a reading room that I know I want to be sunny but not glary. I'm thinking maybe I want a corridor that is sunny in the winter but not in the summer. I can even at this point very quickly start playing with ideas that I can then expand upon in my massing, architectural massing. So what I did next then is I added shading. And the shading I added was in the third, so my third massing, let me turn off my, remember if I come up here in my results and I click on this, deselect all, deselects. Um, so, and again, those got deleted somehow, but so massing two was just this same volume moved closer to the south. Um, massing three is this, and then I added this shading. And how did I just determine the size of that shading? Well, I might have gone back to my site analysis tab and checked out the shadows and run through with and without the shading and thought about, when, if I'm trying to get some shading on the south in the winter, so let's go to the winter solstice. Um, no, I'm saying I'm trying to let the sun come through as much as possible in the south. I can see that between like, let's do the typical not between nine. I could get some light up here. Probably get plenty of light on the east. So that's a good way to look at this. I've got a lot on the east. Um, and then at noon, I've got a fair amount of sun over here on the west, but not on the east, which makes sense. And then at three, I've also got, so it looks like if I focus at the top here and don't, uh, that I could really get some sun coming into the building along here. And then if I say, okay, but what about in the summer? Because I don't want it coming in the summer. I go to here. Um, unfortunately, it's sunny all the time. So I think, okay, well, what if I add some shading? And I see, this is even maybe larger than I need it to be. I don't know. Because I can't remember what I did. That here at least at the solstice, I'm completely blocking that sun coming in there. I think kind of all day. So that looks good. Now, of course, if I get toward, let me go to noon. If I get toward August or something, it's now here I'm in July. In August, I'm starting to get some sun. September. So, I could make this larger if I really wanted to. I wanted to make sure I didn't get any sun in the summer, but then I would probably be blocking some in the winter. But anyway, so the point is I can quickly play around and get some idea of the size of these overhangs I might want to try. Then I go run a simulation. And that's what I did. I ran this one. So we can see better, I'm going to turn everything off. Go ahead and turn the buildings off and my shading. So we can see that this makes sense, right? These are the patterns from the shading. And if we look at, and this is all year, let's actually go, well, we'll just stay with all year right now. I can see that I'm, and why am I getting more shading down the bottom? It's because this, well, just think about it. Turn on your shading and look at it and think about why it's additive basically. But so down here, low in the building, 232. Here I'm at 163. So that's a pretty considerable cut. But let's go look at winter versus summer. So in the winter, I appear am getting 156, 140. So, let's say in the 150 area. And then if I add that's with the shading. If I take the shading off, 180. So it's really not that much different. So I'm actually doing a pretty good job. I'm getting a fair amount of sun still in here in the winter, um, with and without the shading. And then if I change this to the summer, then I see that um, with the shading, I'm getting very little, 30, and without it, I'm getting 65. So I'm still getting some, but so maybe I want to try a larger shading. But it's, this is 30 here. Um, so that's the process, right? Um, and it may seem like this is painstaking to some degree, but if you think about it in terms of you're not building anything, you're drawing it uh, quickly in a model, and the more you do it, the more quickly you'll be drawing it. And this isn't, you're not having to build a mock-up, a physical mock-up. You're not having to even go to the site to do a lot of this. So it's actually super efficient way of learning about the site from an environmental uh, resources standpoint, and we're quantifying the resources. And then we did a whole thing with let me just quickly get over to that. Yeah, I guess I didn't save the file at that point, so I'm just going to recreate it. I'm going to quickly remind you that we did a couple other things that were not required, but they were taking the same information and just getting other outputs from it that are useful at this point also. So I'm going to turn this into a thermal zone. I'm now in the thermal analysis tab. So I'm going to select my massing. Oh, but wait, that's right. I needed to. Um, good point. See, now I've got an energy layer. Why do I have that? Well, for one reason, it's because, maybe I even did have this on already. I'm going to turn off my radiation map layer. And I'm going to turn off my site for now, just so we know what we're dealing with. I'm going to turn off that. So this is my zone, and you notice it's not exploded. It's because this is just surfaces wrapping a volume of air. I then came into my thermal analysis simulation that we're going to cover in detail later in the semester. I selected my zone. This was a template that we just said, leave whatever is there. We'll talk about it in more detail later, but we're going to still be able to quickly get an output. The first thing we notice is that we have these blue things are obviously windows. The reason those were put there is because we can set the window to wall ratio. We can start high and go low, or the other way around. This is probably what you guys typically do with your curtain wall systems that it seems like are really popular with students in New York City. So then we ran this with using, and this is where I exploded out just the surfaces, because I went and looked and figured out based on, I turned the sun on again and moved around which surfaces I thought were going to shade the building, and only use those because it takes up a lot of number crunching power to just think about it. What's happening here is that the program is saying, okay, I'm going to take this surface, I'm going to move the sun through its entire path. So let's go back and look at that really quickly. Right, we have the sun path. I'm going to move through the entire year, with the sun moves, and I'm going to calculate how much sun is hitting that using we have to have the cosine of the direct normal plus the diffuse horizontal. That equals the global horizontal, the total. You got to calculate that for every single hour of the year for each surface. That's a lot of number crunching. Believe me, just have fewer surfaces. You're gonna go much faster and enjoy better the process. So that's what I did when I if I ran it with shading. But the point is, so what did I do? I have a zone. If I go back to my thermal zone, we'll see it. It's got a certain window to wall ratio. I ran a simulation. So I did it, in this case, I did the 0.4 window to wall ratio. So let me just go back to be consistent. I'll just change that to 0.4. I got there's a lot of things we can look at here. We will later, but for this quick little demo, I was just saying we can actually quickly estimate how much energy our building is going to use relative to different decisions we might want to be thinking about right now. For example, the amount of glass. And so I'm using 168 kilobTUs per square foot. That's called EUI, energy use intensity, with this configuration. And that's, let's see what I say here. That is without building context. So then I turned on this building context shading. But if I were making a graphic, I'd go ahead and add everything just to see it. And when I ran that, I had 180. So I went from 168 to 180. What's the difference? I could quickly, and again, these are all estimates, but it's way better than nothing. I could go 168 divided by 180, and I've got about a 7% reduction in my energy efficiency when I bring the context in, which is the real situation, right? Um, then I changed it to the the window wall ratio of 0.8. So that would be this. But again, I'll have to change it. I've already run it. I'm just showing you what it looks like. And if I don't have buildings on, uh, the difference was 168 to 204. So we're saying that that just one way to compare them, 168 divided by 204 for the amount of energy used with either zero point 0.4, a window to wall ratio of 40% or one of 80%. We have an 18% more energy usage with the 80% window to wall ratio. And then I ran a natural ventilation uh, simulation with the same configuration, and I found out that I could go from 204 to 193 by adding natural ventilation. 193 divided by 204. So we gain about 5.5% efficiency if we're thinking about natural ventilation. By the way, that oh, by the way, so well, I won't even talk about that right now. We go to Grasshopper. This was the script I used, and I went over in class. Uh, I'm bringing that up again. You don't have to use that. Maybe a couple of you will because it's interesting and it's something you can do now. That's the whole point of this. Is that there's a lot we can do without even any design, just massing from the program. By the way, I did put that. Um, I put those scripts in resources under software. I have a Grasshopper scripts folder. So all the Grasshopper scripts that I've given you so far this semester are in there, and I'll continue to add them there if we have more. Okay, so that's what I've got. Some of that was repetitive from class to be reviewed, just to try to go over these outputs. Then talked a fair amount about the layers. Hopefully that was helpful. And I made the point about the glitch I had in class and why that's going to be probably it's going to happen sometimes because I'm using a somewhat experimental version of Climate Studio. And it shouldn't happen to you, but oh, here's a final point if anybody's still listening. Um, the way I fixed it was I just closed out and opened up again. I'm amazed, I've been using computers a long time as how often that's true. If I just go, let me just start again, some calculation got in front of some other calculation that wasn't supposed to be in that order or whatever it was, and it's glitching out. If you close the whole computer and open up again, that's the next level, and that fixes a lot of mistakes or a lot of problems. And that's all I did that day in class. All right, anyway, I hope that helped, and I will see you guys in class.